have to escort you out of that seat. Respectfully.
Why's your seat up?
What did you say?
Said of course everyone gets into gambling now as soon as I lose all my money.
What gambling is going on now?
There's online gambling, are you kidding me?
I did not know that was currently going through the school. No.
It happens every year. Last year, same thing.
Mr. Google, guess how much money I won last year on the last day of school? Almost a year ago now.
How much?
2,500.
Nice.
One game.
I asked a student. It wasn't a Prove It student, but like the idea of like doing games in Prove It House for open house, because Ellis open house, everybody likes the thing, like games, like you want the games, and they're like, no. I'm like, why? Because the cool thing about Ellis is not the games, is that you get to dress up and you get to gamble.
Like we gambled on open house, we made 250.
Nice.
Pretty good.
How did you make 250 from gambling in open house?
Felix was going crazy.
I thought Felix only made 50.
No, Felix, we pulled out like $250 something, and then we split it. Like he took like 60%, I think I took like 25, and we gave, or no, I forget how much I took. I only took a little bit, and we had to give some to Maxim because Maxim gave us some cash also.
Oh yeah, I remember with that.
But how did you bet on the open house?
It was like online.
Yeah, we set up a TV and put online gambling
in the
high roller room.
In the high roller room.
Okay.
Miss Allen was watching for a bit, but I don't think she understood it was real money.
Fair enough. At this point, your money is your own. Hopefully make enough to pay for your tuition. If not, I'll see you at Subway. Actually, if you call us Hanford work at Subway. Okay. Notes out. We are going to get started. We have a demo first. We are going to do this reaction as our demo. What I would like you to do is identify oxidizing agent, reducing agent, which one's being reduced, which one's being oxidized. Pull that out for the demo. We're probably going to have to do this demo outside. So this is the same old sheet. This don't ignore what's on the board. Put away your laptops and listen for notes. Glad put away your phone.
I'm doing your.
I thought we were doing the demo.
Pardon? I'm getting it set up right now. Oh, you're doing it.
Your shoes. I'm writing a lot. Would you put the least? Kenny? I'll put it like. He's chill. I feel like.
So do you know how to do that?
No, he's good, but he's gonna be grab. Yeah. Which one? Oh, I'm not doing that right now. No. We did this before the break. We're on you.
Oh.
can you pull that desk out of the way?
So are we finding oxidizing and reducing?
So, oxidizing agent, reducing agent, which one's oxidized, which one's reduced? Given that it involves oxygens, this might be fairly easy. And we might actually be doing this particular demo. Out to the side.
I'm so confused. There's a kind of oxidizing and reducing agent. So whenever we do electrons, oh, this thing?
Also, this particular demo, often it doesn't work because you have to dry the powder. I've got aluminum powder and iron oxide powder. You have to dry it for days. And I found a recipe that says, no, don't do that. Just use the starter solution. And so I have a bit of starter that I'm going to use that might actually work. Okay. Now this. Why did I do it? Oh, you don't need it. But I will say, grab some laptop. And then you can join me in my classroom.
Let me figure it out. Hey, Madeline. I feel like I don't look Hi, Justin. Hello. Hello. Wait, Logan, do you think I should come to Progressives? Yeah? Unless you want to stay and go to school. Like, I have schoolwork, but I don't really want to go to school. But, like, I can probably just text you right after the video. Like, we missed, like, 5 days.
Wait, can you kill people?
Yeah. So just Wednesday, Thursday, they invite you to go? Yeah, I don't think so. I think it's good.
Hey, roll a spawn camping. I wasn't
Hey, can you get out? Can you get out?
Because, like,
That's the fun. It's right. Is that one upstairs? Yeah.
it's hot. Okay. There's lots of seats if you like.
Every time I see them, I'm just like,
No.
oh,
Yeah, that's right.
I know my phone.
It doesn't matter. It
I
doesn't
don't
matter.
have it with me.
We're on you.
No, we're not. We're on that one.
I'm gonna be there.
Yeah. All this gets oxidized. Which one gets oxidized? That's right. You're right.
Oh, well, they're up
Gain
there.
your positive charge, so it's losing electrons. So it's like,
You can, there's seats over here.
It sounds like so gifted. It's like,
Well, and I when I saw her, I was like, oh, she's using that.
She's good on math.
should I?
Does you believe that Earth is flat?
I think it's for our thing.
Yes.
No, she's
Because I was like,
Okay.
we can leave.
Like attention. Put away your devices, notes, whatever. This is Wild Berry Cheerios. I picked Cheerios because it is known to have on its ingredient list. It will change depending on the year, but they'll have it listed as either they fortify it with vitamins and minerals. So it often has listed reduced iron. What is a reduction? Gaining of electrons. So what kind of iron would be reduced iron? Non-charged. What kind of iron is iron that doesn't have a charge? Let's do that. If it doesn't have a charge, it's just. Can you close your laptop? Sam? No online gambling now. Save it for later. So, this just speeds up the process a little bit. I am grinding up the Cheerios. If I could have you inspect the magnetic bar to make sure I don't have anything on it. It's a bit like a magic trick. Pass it around.
Yo, throw it over here.
And then you take that yummy Cheerios and we essentially make a nice cereal. Technically speaking, if you are low in iron, if you ate the cereal with orange juice instead of milk, it would be better for you. Okay, where's the magnetic bar? Bring it on up. Pop it in there. Yep. Okay. Here's your magic demo. We've taken the cereal. We've added it to water. We're going to spin the crap out of it. Make sure that it is thoroughly dissolved. You want it in there until it's that nice mushy paste. And go, get the machine. Excellent. I just need to rinse off my hands if somebody would like some cereal.
Is this the one that's on the board?
Nope, this is completely different. Just Okay. Now, not a chemical reaction. I'm only going to show you reduced iron, which is one form of iron. It means it cannot be charged, which means, I don't know if I was given enough time. Let's see. That came out just about perfect. What do you see on the end of that bar? There are iron filings. This is just straight metallic iron. When they say they fortify your cereal with iron, they mean they took a chunk of iron and they got shavings off of it and they threw it in your cereal. A little bit of acid, citric acid, will actually help it turn it from, it'll help oxidize it, which will make it more absorbable. You don't absorb a lot when it's metallic iron, but you absorb some. Some Canadian scientists became famous, quote unquote. There was, in Cambodia for a while, the number one deficiency that they had was an iron deficiency. And one of the ways you can cure that is by cooking in cast iron pans, because the cast iron pans will leach some iron into it. But that's also very expensive. So they made a little iron bar that you just throw into your soup, and a little bit of iron will come out, especially if you're boiling it. And then you can use that to increase the iron. They tried it, nobody wanted it, it didn't work. So they made it into a lotus flower, and that also didn't work. So then they asked them around and said, you know, what kind of animals are popular? And someone mentioned that fish were lucky during cooking. So they made it into a little fish, and the amount of anemia went down, and it's not a product you can buy. If you buy one online, they also donate them to people in areas that are iron deficient. So when you're talking about reduced iron, or it just says iron on your cereal, they literally mean iron. It's not as absorbable if you're eating, say, liver, because that's a heme iron. It's already got a charge. It's bound to a hemoglobin or some sort of heme body. It's easier to absorb, but you'll still absorb some of this. So the iron you're getting from cereal is literally just iron shavings. And so sometimes they'll label it reduced iron in order to make it seem more fancy. But it's just iron. Now for the next demo, I showed you that one first, so I can claim I showed you a demo today, even if this one doesn't work. The next demo, if it works, will be great. I have mixed results. Sometimes I have to dry the powder for days, but I found a new version that claims if I add a starter material, we can get it to go. So what is iron oxide? Common term. Take iron, add oxygen, what is it? Iron oxide is? Rust. So we just took some rust, and we took pure aluminum, like your aluminum pans. And we're just going to add a little bit of heat. So I'm going to start it with a magnesium ribbon. There's a little bit of white powder on top, and that's the starter. So I took some potassium chlorate, added a bit of sugar. That's white. But you can see the deep rust color below. So it's that and powdered aluminum. Say ooh, ah when you see it. Iron, I believe, melts at about 1500 degrees Celsius or above. Somebody could fact check me on that. That would be great. So we should get, if this is going to work, pure molten iron. There. So the white powder is not the actual reactant, that's just the starter powder to get the heat high enough. And that's hopefully to make it less likely that it will be done. 600? Only 600? Now I'm sad. Maybe I remembered Fahrenheit. We're making, you said the magic word. What is it?
Thermite.
So this is the famous thermite reaction.
Love thermite.
going to do this in the classroom because I think this is the most dangerous demo that I could do. So I need someone whose lives I could probably explain your death. Come.
Okay.
Carefully carry this to the door. If it gets hot, throw it away. Come.
We have 4 more classes.
Alex, I don't know.
We've only done one of the letters. 4 more letters. They're supposed to do it.
Light it, it melts the steel so much.
Bro, I think this is the same thing we did with Mr. McCarthy.
Oh, you did?
No, I don't think so. Not this.
You probably did prove it because you was.
That's what he did, but it didn't work.
can you return the glasses for me, please? You can smell. Oh my gosh, our glasses are open.
It's not meant for cooking something else.
Yeah.
Alright.
And we got other years.
Bro, he's literally gonna come back in 5 fucking
It's like all lies as if you haven't done your children for like all this for
87 is like the minimum or not.
Okay.
Representative average for things as well.
Yeah, thank you.
Maybe step back so you took.
I didn't take any APs in school.
How were you grade 10 grades?
My grade 10s were like
Yo,
70.
what time is it?
My grade 12 was a 93.
That's weird.
So literally my grade 10 was like 70 after.
Let's wait till he comes in here, then we'll leave.
What? So where is any easy leaving?
Well, he's not.
Now you've also just seen one of the reactions that was used in one of the conspiracy theories behind 9/11. If you have steel beams, that is hot enough to melt iron. So one of the conspiracy theories was they packed the steel beams with thermite reaction, and then the government caused them to melt at the right moment. It wasn't
Think
due
it's
to
true?
the
I
blast.
believe that?
I think when World War II, I think he used the thermite.
Well, no, no chemist believes that theory. It's people who've seen the thermite reaction, know it gets hot enough, they believe it. You saw how that went. Thermite melts iron, but it also moves with gravity. It just hit the pot and stopped. To get it to go through, it doesn't go through a beam, it would just be on the outside and drop. You'd have to use so much thermite to get that to happen. I think all the Mythbusters episodes are now online. They did manage to cut a car in half with thermite, so they just put bags and bags of this powder on the middle of a car, and then eventually cut through the engine block, as well as the car itself. It took a lot of thermite, because although it gets that hot, melting something doesn't take it out very quickly. And it wants to go down with gravity, so cutting through a car was okay, but cutting through something that's vertical like a block, not going to go sideways. But you'll find it online every once in a while. Okay, pull out your notes. We're still on PLO or KBAT S. Identify strengths of redox reactions from a table. Oh, yeah, so I did ask you for that. So, what is happening to aluminum? Is it being oxidized or reduced?
It's being oxidized.
Oxidized. And the fastest way to know, even if you don't know the charge, is that it's going from nothing to oxygen, so oxidized. But what's its charge here? Like, what's its oxidation number?
3.
Plus 3. And what's it here? 0. And is iron being reduced or oxidized? Reduced. Because the oxygen's going away, so you're making the molten metal. The charge here is plus 3, that's also 0. So now we can see that oxidized loss of electrons, gain of electron, which makes this the what? Oxidizing agent or the reducing agent? And that would then be the oxidizing agent. So the oxidizing agent in this case is providing the oxygen. That's why it's an oxidizing agent. It itself is reduced because it's handing it over. Now, in the broader sense, it doesn't have to be oxygen. It just often is that way. It's the original naming. But if it was aluminum and iron chloride, the exact same reaction could occur. It's just that chlorine would be the one that's moving things. Aluminum is a highly reactive metal, especially if you can get through that aluminum oxide coating on the outside. If you have you bought a car, it's got an aluminum engine, and you spray it with hydrochloric acid, it'll bubble and it will start to corrode and go away. If you get a variety of chemicals on it, it will react really easily. It's a lot more, it's fairly stable just because we don't let it come into contact with those things, but you can really mess up someone's aluminum engine block. Okay, pull out your data table. Hopefully I have one here. There we go. We have a new table, and it is written as half reactions. Can you find iron plus 3 somewhere around here? Anybody see iron plus 3? This is a terrible conversion. It's all blurry. Need to get a better version. Iron plus 3? Where is it? Give me the number next to it. 0.77, so that makes it here. Excellent. So iron plus 3. Now that only goes to iron plus 2. And you can keep cascading down. Is there any other iron plus 3s? There. Or find iron plus 2. Then we have iron plus 2. There. And now aluminum. Negative 1.66. One of the things we're going to show you is you find your reactants. So here's iron plus 3. And our actual reactant is aluminum. Can I get that all on one board? No. They're too far away. And look at the drop from here all the way down to aluminum solid. When you're finding your reactants, if you have a downhill like that, the table's set up so that a downhill lets you know that that's a spontaneous reaction. That reaction, once it was going, went on its own, released everything, did everything. If you want to go backwards, if you were trying to go aluminum that way, that would require an equivalent amount of energy. What is the energy called to get that reaction going? That was the very beginning of the year. Louder? Activation energy. So it required a fair amount of activation energy, but once you did that, it gives off a ton of energy as well. And just goes on its own. So while you have this table out, noticing a few things. Where are all the metals and where are all the non-metals on average?
Metals at the bottom.
Metals in the bottom tend to be. Non-metals then on top. Downhill reactions then tend to be some non-metal to a metal, which makes sense. Metals tend to get oxidized. This is also a reduction table. So they're written as reductions. If you reverse them, if you just write them the other way, then you have an oxidation. So it just matters which way you write them, in the same way that your acid-base table is just written as acids, but you could write it the other way, and then you'd have a base. Metals in the bottoms, non-metals on top. Reducing agents then are here, because these are the things that are oxidized, and the oxidizing agents are here, because these are the things that are reduced, to go over the language again. So keeping that out, this is just showing these points of the table. You have non-metals, metals, stronger oxidizing agent, stronger reducing agent. So this is meant to just mimic the table. You'll notice there's a 0 voltage. If I go back to it, if you went from, let's say you did a spontaneous reaction from H plus down to cobalt, how many volts would you get out of that?
Negative 0.26.
Well, we know it's spontaneous, so would you get negative volts?
Well, 2.22.
Yeah, you'd take 0. And so how it works is you just take that and you minus. So 0 minus negative 28 becomes 28. Is it 28 or 26?
It looks like 26.
Okay, 26. So if you had hydrogen and you're reacting it with iron, in this particular case. So we take that fresh iron we made. How many volts would we get out of that?
45.
0.45, yeah. We're always starting in a position of 0. What if I started from copper plus 2? Would we get out more or less volts?
You get more.
You get more. I think someone said it. So what would you get if we went from
0.60.
0.60? Yep. Because we have 0.15 minus negative 45. So you can always do it that way. Yep.
I was just wondering, because of the charges, you do not have to balance these equations.
We're doing balancing next. So we do balance those, but we balance it in a different way.
Okay.
Yeah. Because we have to take into account the number of electrons. That one's probably pretty simple, because if you just balance it like you normally will, I think you'll get the right answer.
Yeah.
But there are versions in which if you can get a balanced equation where the number of atoms match on both sides, but if you look very closely, the oxidation numbers don't. And then you haven't balanced it correctly, and you have to do it again.
Okay.
But we're doing that very, very next. Back to here. All values below it are negative. Oh! So everything below hydrogen, you'll notice the strength of the oxidizing agents here. So these are very, very strong oxidizing agents. They would really, really, really like to be reduced. We know that fluorine gas is a very reactive gas. This is one of the reasons why. It desperately, desperately wants to have that extra electron. Once you get to about hydrogen here, where we picked as 0, and by the way, we picked it as 0. They're all done relative to this cell. We could have made 0 any one of these that we wanted. We picked hydrogen as a standard reaction because it is about halfway through the table. And then as we get down here, these are all very, very negative voltages. They really want to go the other way. So these would really like to lose electrons. So these would really like to become oxidized. So these are very strong reducing agents. And it's labeled on here. Very important that you pay attention to the over-potential effect. The over-potential effect is something, all right, we got there, and let's pick something, oh, did that work? That might work. Nope. Nope, last detail of the over-potential effect. That you can erase because you aren't allowed to consider it in chemistry 12. It's required to be there, and I mention it so that university you'll know you have to deal with it, and then we ignore it for the rest of the time. 12. Okay, next day we'll do spontaneity, and we'll talk about how much. Oh, bring your lab books next day. Okay? Lab books. Oh, we have a lab.
We have a lab?
Bring your lab
We have
books.
4 letters left.
Bring your lab book.
Okay.
Bring your lab book.
Thank you.
Thank you.
You're welcome. And now I will deal with my very messy demo.
You mean wrap up the cords over here?
Hmm?
You mean to get wrap up the cords over here?
Oh yeah, if you throw it into that box, that would be lovely. Thank you. That's the first time I've actually had it go that fast. I've had it not go at all, and so this time I did everything I could think of to make it go fast. I think I actually made it go too fast.
Yeah, okay, it kind of went.
It was, and it was gone. Now I didn't have to worry about trying to slow it down.
God, your cable management is not good.
No, this is just upsetting me as a theater pro.
it is not. Do you guys learn the proper way of rolling too, where you take into account that it doesn't? Yes, you are.
Personally, like my go-to is gonna do a modified version where I keep it still using a couple hands.
Ah, okay. That makes sense.
So I can just do this. And it's easier for longer chord.